Mercury. As you approach Mercury, the planet feels exposed in a way Earth never does. There's no haze, no clouds, no atmosphere softening the view. The sun dominates the sky, appearing more than twice as large as it is seen from Earth. Light is harsh and unfiltered. Let's assume you manage to land. That alone is difficult, as Mercury has almost no atmosphere to slow a spacecraft down. When you step outside, you're essentially stepping into space. Surface pressure here is close to zero compared to Earth's 1 bar pressure, which means air can't behave normally on Mercury. Temperature becomes the next shock. In sunlight, the ground reaches about 430 degrees Celsius. In darkness, it drops to minus 180 degrees Celsius. On Earth, air spreads heat gradually. Here, there's nothing to slow the change. Even if your suit protects you from the temperature, pressure doesn't give you time. Oxygen can't stay in your bloodstream, and within seconds, consciousness fades. Mercury doesn't attack violently, it simply offers no conditions for survival. Venus. From space, Venus doesn't look immediately hostile. It's very close to Earth, sometimes just 40 million kilometers away, and it is nearly the same size, and Venus is often called Earth's twin. Gravity is familiar, about 90% of Earth's gravity, so at first, it feels like a place you could stand. Let's assume you begin your descent. Thick yellow clouds surround the planet, stretching endlessly in every direction. Sunlight fades quickly. Less than 10% of it ever reaches the surface. These clouds are made of sulfuric acid, which is highly corrosive and toxic. But let's assume your suit can handle that. The real problem starts lower down. With every kilometer, the air grows heavier. It's mostly carbon dioxide packed tightly by gravity. By the time you reach the surface, pressure has climbed to about 92 bars. On Earth, pressure at sea level is 1 bar. This is like standing nearly 900 meters underwater. Movement becomes slow and exhausting, as if you're pushing through dense liquid. Then there's the heat. Surface temperatures average around 465 degrees Celsius, hotter than Mercury despite being farther from the sun. Suit cooling systems fail almost immediately. Even if your suit holds for a moment, the atmosphere doesn't. On Venus, the air itself is what ends the attempt. Mars. From orbit, it looks familiar. Dusty plains, deep valleys, polar ice caps. In some places, daytime temperatures can even reach around 20 degrees Celsius, similar to a cool day on Earth. At first glance, it doesn't feel deadly. Let's assume you step outside. The problem isn't temperature, it's the air. Mars's surface pressure averages about 0.6 kilopascals compared to Earth's 101 kilopascals. That difference means the atmosphere can't support normal breathing without a suit. Within about 15 to 20 seconds, your brain can no longer stay conscious. Wind speeds on Mars can reach up to 100 kilometers per hour, which can damage equipment. Heat escapes quickly because the air is too thin to hold it, and Mars has no global magnetic field to block radiation. On average, radiation exposure here is 40 to 50 times higher than on Earth. Mars doesn't overwhelm you instantly. It feels calm, quiet, almost welcoming. And that's what makes it dangerous. It removes the conditions your body depends on without ever looking hostile. Jupiter. You never really arrive at Jupiter. There's no surface waiting for you, only layers. Long before you get close, Jupiter introduces its first problem: radiation. Its magnetic field is the strongest in the solar system, and even about 300,000 kilometers away, radiation levels are high enough to damage spacecraft electronics. Let's assume your suit can block that, because otherwise the journey ends here. As you descend into the atmosphere, gravity takes over. Jupiter's gravity is about 2.4 times stronger than Earth's, so you accelerate rapidly. There's no ground to aim for, only endless clouds below. The first layers are pale and turbulent, made of frozen ammonia crystals. Temperatures here hover around minus 150 degrees Celsius, while winds scream past at over 480 kilometers per hour. Staying stable is nearly impossible. After falling roughly 150 kilometers, you've already gone deeper than any spacecraft ever has. This is where NASA's Galileo probe was destroyed in 1995. Below that, pressure rises violently, adding Earth-like pressure every few kilometers. Gas turns into a dense, crushing fluid. Hydrogen becomes metallic. Deeper still, temperatures climb to around 24,000 degrees Celsius, several times hotter than the sun's surface. On Jupiter, survival doesn't end suddenly. It ends layer by layer as falling never stops. Saturn. From far away, Saturn looks calm, almost elegant. Its rings stretch wider than the distance between Earth and the Moon, made of ice and rock, drifting silently in space. Compared to Jupiter, Saturn feels less aggressive, less chaotic. You enter its atmosphere. At first, gravity feels surprisingly normal. Saturn's gravity is close to Earth's, so movement doesn't immediately feel dangerous. That familiarity is misleading. The atmosphere is made almost entirely of hydrogen and helium, with no oxygen at all. There is nowhere you can breathe. As you descend, winds begin to dominate. Speeds exceed 1,800 kilometers per hour, faster than any hurricane ever recorded on Earth. Storms span thousands of kilometers and never fully settle. Staying upright or stable becomes impossible. Upper layers are brutally cold around minus 250 degrees Celsius, plunging far below survivable temperatures. As you fall deeper, the cold eases slightly to 0 degrees Celsius, but pressure replaces it as the main threat. Gas compresses into dense fluid, squeezing tighter with every kilometer. There's no surface to land on and no safe layer to reach. Uranus. By the time you reach Uranus, the sun no longer feels like the center of the solar system. At nearly 3 billion kilometers away, sunlight is faint and cold. The planet itself looks calm from a distance, wrapped in a smooth blue-green haze. Let's assume you descend into its atmosphere. Uranus is tilted almost completely on its side at about 98 degrees, which creates extreme and endless seasons. The atmosphere is made mostly of hydrogen, helium, and methane, giving it that pale color but offering no oxygen at all. Average temperatures hover around minus 224 degrees Celsius, which is colder than liquid nitrogen on Earth. At first, the cold is the dominant threat, as heat drains from your body faster than any insulation can replace it. Winds quickly pick up, exceeding 250 kilometers per hour, cutting through the atmosphere without slowing. As you fall deeper, pressure begins to rise, compressing the gases into heavier layers. Under these conditions, the environment never stabilizes. There's no warmer zone to reach, no calm layer to hide in. Neptune. Neptune is so far from the sun that it barely feels real. At about 4.5 billion kilometers away, sunlight is weak, more like a bright star than a source of warmth. From a distance, the planet looks calm and deep blue, almost peaceful. When you enter its atmosphere, almost immediately movement becomes a problem. Neptune has the fastest winds in the solar system, measured at over 2,000 kilometers per hour, faster than the speed of sound and far beyond anything experienced on Earth. These winds don't just push, they tear sideways, making control nearly impossible. Temperatures in the upper atmosphere sit around minus 214 degrees Celsius, cold enough to shut down most systems quickly. There's no oxygen to breathe and no solid surface to reach. As you descend, pressure increases steadily while the cold never truly lets up. Unlike Uranus, Neptune also generates heat from within. Deeper layers grow warmer but not safer. Pressure and motion combine, crushing and destabilizing everything at once. Neptune never gives you a moment to adjust. It's a planet of constant motion, cold, fast, and relentless, where nothing stays still long enough for survival to even be considered. Subscribe for more journeys into places where survival depends on the environment, not luck.